If we were to take all of the volcanoes in the world and freeze them, what would happen? How much land would be covered in ice? How high would an ice wall around the world get? And how long would it last? To answer these questions, we need to find out how much magma is produced by volcanoes every year. It turns out that from 2000 to 2018, there are 768 million cubic meters of magma produced by volcanoes each year. If we took this rock and spread it evenly over the Earth's surface, we would cover about 19 hectares of land with new rock. In other words, if we froze all the volcanoes in the world, not only would the land area increase by 19 hectares, but all the extra rock would also make the tallest mountain on Earth, Mount Everest, more than 64 meters taller. The increased height of Mount Everest alone would result in an additional 3.5 billion cubic meters of rock. However, we would still have 73.28 billion cubic meters of rock left over. If we spread this rock evenly around Mount Everest's base, we could build a wall around the entire planet that would be 101.6 meters high. So to answer our first question, if we froze all the volcanoes in the world, we would cover 19 hectares of land with new rock and create a giant ice wall around the world that would be 101.6 meters high. But how long would this ice wall last? For that, we need to find out how much magma is produced by volcanoes during a volcanic eruption. During a volcanic eruption, magma is pushed from deep within the Earth to the surface. As it rises, the pressure around it decreases, which causes dissolved gases in the magma to expand and form bubbles. When the bubbles reach a certain size, they burst and the magma fragments into ash and rock. This process is called fragmentation, and it is responsible for the explosive nature of volcanic eruptions. The amount of magma that is fragmented during an eruption depends on several factors, including the amount of gas in the magma, the viscosity of the magma, and the rate at which it is released. The amount of gas in the magma is important because the more gas there is, the more bubbles will form and the more explosive the eruption will be. The viscosity of the magma is also important because the more viscous the magma is, the less gas can escape, and the more explosive the eruption will be. Finally, the rate at which the magma is released also plays a role. The faster the magma is released, the less time the gas has to escape, and the more explosive the eruption will be. On average, during a volcanic eruption, about 5% of the magma is fragmented and thrown into the air. However, depending on the factors we mentioned earlier, this percentage can vary greatly. Some eruptions are so mild that only a fraction of a percent of the magma is fragmented, while others are so violent that more than half of the magma is fragmented. Now that we know how much magma is fragmented during an eruption, we can calculate how much rock is lost to erosion each year. On average, volcanoes lose about 0.05 of their total volume to erosion each year. This means that Mount Everest, which has a volume of 1.89 billion cubic meters, loses about 94.5 million cubic meters of rock to erosion each year. So to answer our second question, if we froze all the volcanoes in the world, the resulting ice wall would lose about 94.5 million cubic meters of rock to erosion each year. But how long would it take for this ice wall to melt completely? The answer depends on many factors such as the thickness of the ice wall, the temperature of the surrounding environment, and the amount of heat received from the sun. However, we can make some estimates based on the average values for these factors. Let's assume that the ice wall is 100 meters thick, which is close to the maximum thickness we calculated earlier. The temperature of the surroundings is 0 degrees Celsius since we are dealing with an ice wall. And let us assume that the ice wall receives the same amount of heat as the rest of the Earth's surface. With these assumptions, we can use a formula to estimate the time it takes for the ice wall to melt completely. The formula takes into account the mass of the ice wall, its heat capacity, the latent heat of fusion of water, the thermal conductivity of ice, and the temperature difference between the ice wall and its surroundings. plugging in the numbers, we find that the ice wall would melt completely in about 47,000 years. So to answer our third question, if we froze all the volcanoes in the world, it would take about 47,000 years for the resulting ice wall to melt completely. Now let's talk about why freezing all the volcanoes in the world would be a bad idea. Volcanoes play an important role in regulating the climate of the planet. They emit gases and particles into the atmosphere that reflect and absorb solar radiation, which helps regulate the amount of heat reaching the Earth's surface. In addition, volcanoes also release water vapor into the atmosphere, which is an important greenhouse gas. If we were to freeze all the volcanoes in the world, we would disrupt this balance and cause significant climate change. Volcanic eruptions can also have short-term effects on the climate. For example, the eruption of Mount Pinatubo in the Philippines in 1991 released large amounts of sulfur dioxide into the atmosphere, which caused global temperatures to drop by about 0.5 degrees Celsius for 2 years. In contrast, the 2011 eruption of Iceland's Eyjafjallajökull volcano caused major disruption to air traffic in Europe due to the ash cloud it released, which led to the cancellation of tens of thousands of flights and stranded millions of passengers. Another reason why freezing all the volcanoes in the world would be a bad idea is that it could lead to the loss of valuable habitats. Many plants and animals live near volcanoes and depend on the unique conditions that these areas provide. For example, the vegetation around volcanic vents often consists of hardy species that are adapted to the harsh conditions of the environment. These plants in turn provide food and shelter for a variety of animals, including insects, birds, and mammals. By freezing all the volcanoes in the world, we would destroy these habitats and cause the extinction of many species. Finally, freezing all the volcanoes in the world would also be a bad idea because it could lead to the release of dangerous substances. Volcanoes contain a variety of potentially harmful substances, including sulfur dioxide, carbon dioxide, and hydrogen sulfide. If we were to freeze all the volcanoes in the world, these substances could be released into the atmosphere and cause respiratory problems and other health issues. In conclusion, freezing all the volcanoes in the world would have serious consequences for the planet and its inhabitants. It would cause significant climate change, habitat loss, and the release of harmful substances. Therefore, it is a bad idea that we should not even consider. Now check out another video. What if everyone became invisible? Or watch another video. What if roads glowed?